Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider and you're watching Learn and Teach by Sir Ayaz. So I was doing the paper 0620 and the variant is 43 and it's of May-June 2023. I'm done till question number 4. So let's continue from question number 5. This question is about electricity and chemical reactions. A. Aqueous copper 2 sulfate is an electrolyte. The electrolysis of aqueous copper 2 sulfate using inert electrodes forms copper at the cathode, oxygen at the anode. Number 1, state what is meant by the term electrolyte. Electrolyte is a liquid. It's usually ionic compound, either in molten state or in aqueous solution that conducts electricity. So you write ionic compound in molten or aqueous conducts electricity. Number 2, state the term given to the Roman numeral 2 in the name copper 2 sulfate, its oxidation number. Of copper here. You have to mention because this number belongs to copper in this name. Number 3, state what happens to the color of the aqueous copper 2 sulfate as this electrolysis progresses. Color fades away or becomes colorless. Becomes colorless or fades. Number 4, write an ionic half equation for the formation of copper at the cathode. Copper gain electron to form copper 2 plus ion gain electrons to form copper metal. So we will balance the equation, 2 moles of electrons. Number 5, give the formula of the ion that forms oxygen at the anode. It's OH negative ion. B. The electrolysis of aqueous copper 2 sulfate is repeated using copper electrodes. State what happens to the anode. So here, if you use copper electrode instead of inert electrode, the electrode will involve during the electrolysis and there will be increase in mass of cathode. And on the other hand, copper anode dissolves because in the solution there will be loss of CO2 plus ion, as CO2 plus ion will get deposited to the cathode, and in order to compensate this loss, the anode dissolves. So you write anode dissolves. C. Spoons can be electroplated with silver. Number 1, name the substances used as the anode, that is positive electrode here. So we need to electroplate spoon with silver. So anode should be of silver and cathode should be of spoon. Spoon should be made cathode. What about the electrolyte? You have to take the aqueous solution of silver nitrate or sulfate. Aqueous solution of silver sulfate or nitrate. Number 2, state 2 reasons why spoons are electroplated in order to improve the appearance and prevent corrosion. Improve appearance Number 2, prevent corrosion. Moving to next part, D. Hydrogen oxygen fuel cells can be used to produce electricity to power cars. Petrol produces carbon dioxide and carbon monoxide when it powers cars. Number one, state one adverse effect of carbon dioxide and carbon monoxide. Carbon dioxide is responsible for global warming, increased global warming. The reason is that carbon dioxide absorbs thermal energy, which is released in the environment, and emits some of this energy to the earth. It prevents the loss of energy, heat energy in the space. That's why there's increase in global warming, increase in the temperature of the earth. Carbon monoxide is poisonous or harmful. Poisonous or toxic. Number two, state one at disadvantage other than cost of using hydrogen oxygen fuel cells to power cars compared to using petrol. You need high pressure vessels to store hydrogen. Needs high pressure to store hydrogen gas. Number six, this question is about nitrogen and compounds of nitrogen. A. Ammonia is manufactured by the reaction between nitrogen and hydrogen in the Haber process. The equation is shown. This is the reaction. N2 gas plus 3H2 gas gives 2NH3 gas. Number one, state the source of nitrogen for the Haber process. Nitrogen is obtained from air. Number two, state the source of hydrogen for the Haber process. It's produced during the cracking of long chain alkanes or from methane. Cracking of long chain alkanes or from methane. Number three, state the typical conditions used in the Haber process. Temperature is 450 degrees centigrade and the pressure is 200 atm. Number four, name the catalyst used in the Haber process. It's iron. You can even write the symbol of iron, that is Fe. Number five, state what is meant by the term catalyst. It's of 2 marks, so you will mention a substance which increases the rate of reaction and remains unchanged at the end of the reaction. A substance that increases the rate of reaction. It remain unchanged at the end of the reaction. Part B, ammonia is converted into nitric acid. Number one, the first stage is the conversion of ammonia into nitrogen monoxide, NO. The equation is shown. This is the equation. 4NH3 gas plus 5O2 gas gives 4NO gas plus 6H2O gas. The reaction is carried out at a temperature of 900 degrees centigrade and a pressure of 7 atm. The forward reaction is exothermic. So for your convenience, I am writing the sign of delta H. It must be minus in the forward direction. And if the forward is exothermic, backward should be endothermic. So the sign for delta H for the backward direction should be positive. Using explanations that do not involve cost, explain why a temperature less than 900 degrees centigrade is not used. So it will decrease the rate of reaction. Decreases the rate of reaction. Explain why a pressure greater than 7 atm is not used. So what will happen if you increase the pressure? The equilibrium will shift to the side with less number of moles. And if you count the number of moles of gases in the equation, on the reactant side, you have 9 mole of gases. And on the product side, you have 10 moles of gases. So you can't have greater pressure. So the equilibrium will shift to the reactant side. Position of equilibrium. Equilibrium shifts to left hand side or reactant side. Number 2, in the second stage, nitrogen monoxide reacts with water and oxygen to produce nitric acid. Balance the symbol equation for the reaction. Here's the equation. We have the reaction between NO plus O2 plus H2O gives HNO3. So in order to balance the number of atoms of each element, so first we'll start with 2. Let's place 2 before HNO3. Hydrogen is balanced. What about nitrogen? I will place 2 here. Now, how I can balance oxygen? On the right hand side, we have 2 multiplied by 3, 6 oxygen. And on the reactant side, we have 2 plus 2 plus 1, 5. So we can't balance it by placing 2 here, because then it will become 2 multiplied by 2, 4, 4 plus 2, 6, 6 plus 1, 7. And I can't place 3 also before HNO3. So let's place 4 before HNO3. Now I have to place 2 before H2O. What about nitrogen? I have to place 4 before NO. Now let's balance oxygen. On the right hand side, we have 12 atoms of oxygen. Oxygen 12. On the reactant side, it is 4 plus 2, 6. So we need 6 more oxygen. So I have to place 3 before O2. Now this equation is balanced. C. A student makes aqueous copper 2 nitrate by adding an excess of solid copper 2 carbonate to dilute nitric acid. Number 1, write the symbol equation for this reaction. You have CuCO3 and it is added to dilute nitric acid. So we have HNO3 for nitric acid. And you want to make copper 2 nitrate. So the formula for copper 2 nitrate, if you want to predict the formula, you have Cu and NO3. Cu is carrying plus 2 charge here. What about NO3? NO3 carries minus 1. Ignore the charges. Subscripts will be exchanged and you will get CuNO3 whole twice. This is reaction between metal carbonate and acid. So the other product should be water, H2O, and carbon dioxide, CO2. Let's balance the equation. We simply place 2 before HNO3. Now it's balanced. Number 2, state 2 observations that indicate the copper 2 carbonate is in excess. No more solid dissolves and the bubbling stops on further addition of copper 2 carbonates. No more solid dissolves or undissolved solid, and bubbling or effervescence stops. On addition of more copper 2 carbonate. This indicates that copper 2 carbonate is in excess. Number 3, name one compound other than copper 2 carbonate that can be added to dilute nitric acid to produce aqueous copper 2 nitrate. You can take copper 2 oxide or copper 2 hydroxide. Copper 2 oxide or copper 2 hydroxide. Moving to next part. Question number 7. This question is about organic compounds. A. Propane and chlorine react at room temperature. An equation for the reaction is shown. This is the reaction. C3H8 plus Cl2 gives C3H7Cl plus HCl. Number 1. State the condition required for this reaction. It needs ultraviolet light to take place. Number 2, draw the displayed formula of two structural isomers with the formula C3H7Cl. So they are talking about the isomers with the formula C3H7Cl. So the isomers must be having different positions of Cl in them. So one must be 1 chloropropane and the second must be 2 chloropropane. For your convenience, I am writing their name: 1 chloropropane and we have 2 chloropropane. The difference is in the position of chlorine. We have 3 carbon atoms here: 1, 2, 3. In 1 chloropropane, we have to place either on the right hand side or left hand side. We have to place chlorine on the right hand side or the left hand side. Let's consider this carbon as number 1. 1, 2, 3. Now I am saturating the carbon atoms with hydrogen. What about 2 chloropropane? Again, we have 3 carbon. 1, 2, 3. I'm counting from right hand side. 1, 2, 3. This time I'm placing the chlorine on the second carbon, Cl. Now let's saturate the carbon with hydrogen. So these two will be the final formula for the structural isomers with the formula C3H7Cl. P. Alkenes are a homologous series of hydrocarbons. One state two characteristics that all members of the same homologous series have in common. So they have same general formula, same chemical properties, same method of preparation. They have same or common functional group. So we'll write any two from same general formula, same functional group, same chemical properties, same or similar method of preparation. Two, addition polymers are made from alkenes. Complete figure 7.1 to show one repeat unit of the addition polymer formed from but2ene. So we need to show one repeat unit of the addition polymer formed from but2ene. So first of all, I'm going to draw the displayed formula of but2ene. We have 4 carbon atoms in but2ene. We have 1, 2, 3, 4. And there must be double bond between second and third carbon atom. It's up to you whether you can start counting the carbon atom from the right hand side or left hand side. You must have double bond between these two. Let's saturate the carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I will place hydrogen. Now, in order to make the polymers, I can draw this but2ene in this way. It's better if you draw in this way, then you can draw the monomer produced during the polymerization. Will be easier for you. Now for the polymers, you simply have to remove this double bond and add up two single bonds on the right and left hand side. This will become the repeat unit for butene. So for this we have CH3, CH3, H, H. So this will be the repeat unit obtained during the addition polymerization of butene. C. A repeat unit of a condensation polymer is shown in figure 7.2. The polymer is made from two monomers. This is figure 7.2 and we have the condensation polymer. Number 1, draw the structures of the monomers used to produce the polymer in figure 7.2. So first of all, I have to pick the monomers. Before that, I have to pick the repeat unit for this one. If you look at the formula carefully, so the repeat unit for this one should be this one. This one will be the one repeat unit and this one will be the second repeat unit. Now I'm drawing the repeat unit for this on the left hand side. So we have C double bond O, CH2, C double bond O, bond. Now what else you will place in order to get the monomer? Because it's a condensation polymer, so it must be having OH group at the end on the both sides. What about the other monomer? It must be O, bond CH2, CH2, bond O, place H. So this will be the final structure of the monomers used in this. Number 2, name the type of condensation polymer in figure 7.2. If you look at this condensation polymer, if you look at the linkage, this linkage is ester linkage. So it must be polyester. Number 3, name the two homologous series to which the monomers in one belong. Look at the monomers. If you look at the functional group in this one, you have carboxylic group. These are carboxylic group, carboxylic acid. What about this one? This one belongs to alcohols. So we have carboxylic acid and alcohols. Carboxylic acids and alcohols. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.